Your 3D model shows zero clashes. Everything looks perfect. But during shutdown, the pump rotor cannot come out. That means your design has already failed. Today, I'll show you the biggest mistake engineers make in 3D model review. Slide 1. What is real 3D review? Most engineers think 3D review means check clashes, fix, done. But that's wrong. A proper 3D review must check physical clashes, functional usability, maintenance access, safety. Because design is not about looks, it's about real-life operation. Slide 2. Types of clashes. There are 3 types of clashes: hard clash, direct overlap, pipe through beam; soft clash, no clearance, no space for tools; functional clash, no maintenance access. And here's the truth: functional clash is the most dangerous because software will not detect it. Slide 3. Most critical: pull space. This is where 90% engineers fail. Pull space is space required to remove components. Example: pump rotor, motor, bearings, coupling. If this space is not available, equipment becomes unmaintainable. Slide 4. Real scenarios. Let's visualize. Pump rotor removal needs full rotor length plus extra clearance. Motor lifting needs vertical crane path. Coupling removal needs space for tools. If even one is blocked, shutdown becomes a nightmare. Slide 5. Maintainability checklist. Always check coupling area, guard removal, tool access, bearing housing, cover removal, sensor access, valves, handwheel rotation, bonnet lifting, instruments, calibration access. If technician can't work, design is wrong. Slide 6. Human access. Design is for people, so check walkway, 600 to 900 millimeters, safe standing space, ladder and platform access, no trip hazards. If a technician cannot stand properly, the design has failed. Slide 7. Piping and structural conflict. One of the biggest mistakes: pipe routed over coupling. Result: guard cannot open, maintenance blocked. Also, structure blocking seal removal, supports blocking access. Always keep maintenance corridor clear. Slide 8. Electrical conflicts. Cable trays are often ignored, but they create major issues: block bolt tightening, block motor lifting, cross-coupling area. Electrical routing must respect mechanical access. Slide 9. Thermal and vibration effect. Even if no clash exists, problems can still occur. Thermal expansion, pipe movement, vibration. Example: pipe expands, hits structure, load transfers to machine. Always check movement, not just position. Slide 10. Review workflow. Follow this step by step. 1. Check machine center line. 2. Identify maintenance side. 3. Validate pull space. 4. Check flange access. 5. Verify valve and instrument access. 6. Check human access. This is professional 3D review. Slide 11. Common failures. These are real failures. Rotor cannot be removed. No space for torque wrench. Motor lifting blocked. Filter cannot be replaced. No walkway. These happen even in clash-free models. Equipment focus. Different equipment, different checks. Pump, rotor pull direction. Compressor, large bundle space. Lube oil skid, filter removal. Always review based on equipment type. Slide 13. Golden principle. Here's the most powerful line: clash-free does not mean maintainable. Your job is not just to avoid clash. Your job is to ensure the machine can be maintained. Slide 14. Final takeaway. Remember this: pull space ensures maintenance, access ensures safety, clearance ensures operation, and most important, design must work in real life, not just in software. If you want to become a top package engineer, you must think like a technician, not just a designer. Like this video. Subscribe for deep engineering content. Comment 3D if you want real failure case breakdowns. See you in the next one.